me draw this out at times at 64 speed. And here are the two setups. On the left, we have a polystyrene cup. That's a good thermal insulator. It will keep any energy released in the system. A thermometer to measure temperature change, and the reaction, possibly an acid and a base or something like that. And make sure the reaction starts in the cup. Don't react it outside.
Okay, and so as always, it's going to be delta H equals minus mc delta T over the moles of fuel. mc delta T is the mass, specific heat capacity, and the temperature change of whatever's going on in there. The moles of fuel, one of the two reactants will be specified for you, and that will be the fuel. People often get this one confused with the other one, so it's important to keep them separate. So the moles of fuel, they'll actually specify which reactant is going to be that mole of fuel.
For the second example, we have a calorimeter. We have some water there, and underneath is a fuel that's being burnt in a burner. And so the energy is going to be transferred by combustion to the water in the can. Some draft proofing will also give you better results.
Once again, the equation is going to be delta H equals minus mc delta T over the moles of fuel. But for the right-hand case, mc delta T, once again, is going to be almost certainly the water that you're heating up in there. And the fuel, it's going to be a bit more obvious, is whatever you're using in that burner there. Not the mass of the fuel, the moles of the fuel. Later videos will cover this in more detail.